There is a secret cabal of people trying to keep you from being your best self. A vast conspiratorial network spans the globe, guarding hidden knowledge, wisdom that enhances the mind, body, and soul of anyone privileged enough to possess it. Just who are these elites? Who are these mysterious agents? And just where did they acquire their skills? The world may never know their true identity. We only know them as question answerers on engineering forums.
Stack Overflow, Stack Exchange, Arduino Forum, Physics Forums, these websites and many others contain a massive vault of incredible insight, and they contain potential solutions to a lot of really niche problems for electronics, coding, or even mechanical projects. Now, I should know, I had to do a bit of a deep dive on a bunch of these forums for a few days this week. You'll see why soon. But man, some of the people on here are rude. They are rude. I've seen so many instances of a question being asked in a super humble manner, sometimes even apologetic for asking a question. And then the reply insults the asker's intelligence and doesn't even answer the question. I mean, what is that? Okay, you're probably wondering where I'm going with this. I promise it's important. If you're new here, hi. My name is Will, and I'm here to provide science and engineering education in a positive and constructive way, all while developing cutting-edge products aimed at making the world a safer place. Right now, these projects are in the early stages. I've got a whole host of devices I'm working on, but lately I've been focusing on two. Charlotte, my little octopod, which I've finally gotten to walk, is soon to receive a new reinforcement learning-based walking algorithm. Future advancements include extreme miniaturization. My wrist-mounted material ejection device, or spray slit, is also due for extreme miniaturization, the first steps of which we will be taking today. As usual, there will be a bunch of fun little side quests here and there. Not because I'm trying to fill time. I always planned this video to be like this. I did. Please believe me. Look, I'm in the home stretch of my PhD, so I'm just trying to keep the videos coming as best I can. It's been a really great way for me to stay consistent with these projects during this insanely busy time. I mean, I didn't know it was even possible to sleep so little. Anyway, I hope you enjoy this next step in the journey, but don't forget to get caught up on my bi-weekly Friday 5 p.m. videos. And remember, all you have to do to support the channel is subscribe. That being said, let's get into it.
Not this again.
You know what, Charlotte? I've had about 6 hours of sleep over the last 3 days, so I could really use a nap.
That's right. Your core submission was sent about 4 minutes before the deadline.
Yeah, that was like 4 hours ago.
I'm sure you did a great job.
Well, it's over. That's the main thing. Now, it's time for sleep.
So your video is coming out in about 30 hours.
Okay.
Help.
Well, it looks like we're gonna have to complete the "Can I make a whole video in a day" challenge.
Did you hear that?
Was that?
I think it is.
Oh boy, now I'm excited. All right, so we just got the brand new surface-mounted PCB from PCBWay. I have no idea what it looks like yet. We're gonna open the box and find out. Here it is, bracelet controller. That's what I've called this project because it's for the bracelet. It will be as versatile as the other PCB, but specifically you'll see why this one is designed for the bracelet. Oh boy, I'm kind of scared. Oh my goodness. I mean, it looks so cool. Wow. I've never done something like this before. Oh my goodness. Oh my gosh, what if it doesn't work? It's beautiful though. It's beautiful. Oh my goodness. Okay. So essentially what we have here, USB-C connection for programming and power. We have a little LED, built-in LED, just like the QT Pi RGB LEDs. We have some power capacitors. Those are for the motor H bridge. We have a little voltage regulator there. That's for 3.3 volt power. Then on the back here, we have the H bridge IC. we have the 5-volt regulator IC, and we have the programmable microcontroller chip. It's the same chip used on the QT Pi. Also, since I've become so fond of these tiny JST connectors, I decided to add some ports right on the board. And it looks like they fit my existing hardware pretty nicely. Wow, this is incredible. So you can see here the difference in size between the whole mount PCB that I ordered from PCBWay that I put together and the surface mount version. Both of these have the exact same capabilities. In fact, this one actually has more capabilities. Oh, this is so exciting. I can't wait. I can't wait to see if it works. The first step in getting a custom microcontroller like this to work is actually to flash this chip with what's called a bootloader. It's sort of the programming that's on the chip by default that allows someone like me to upload a custom sketch. It's the thing you write in C code in the Arduino IDE. So we're gonna see if we can flash the bootloader to this guy. And if we can, and we can upload our own sketches, this is a very exciting thing. But that, might require some trial and error. I really hope this works. Mwah. I'm so happy to still have time to do this after the Coral paper.
Conference on Robot Learning. I wish you could confer on my robotics till I learn that RL policy you're always yapping about.
Okay, you know what? You get magnets on your feet. That's what you get this week. Okay?
Okay.
So I've always wanted Charlotte to be able to climb walls, and I was thinking of my own methods of doing this, like with dry adhesion or little fish hooks or something like that. Commenters actually suggested magnets. I actually had 2 people suggest magnets for Charlotte's wall climbing abilities. One of which was a commenter, one of which was my girlfriend, who's also an engineer. I kind of feel like it would work, honestly, but I don't want to waste any time with it. What we're going to do is some measurement and some calculation to see if this is really feasible. So let's assume we have 2 problems to solve here. Here's our gravity vector. First problem is Charlotte standing on the ceiling. So she has a magnetic foot here. Let's assume that this foot needs to be able to hold 1/3 of Charlotte's weight, meaning we're assuming she can have 3 feet on the wall at any given time. Next problem is we've got Charlotte walking upward on a wall. And once again, we know Charlotte can have 3 feet on the wall at any given time. So we know that the static friction force here has to be at least mg/3. And so here the coefficient of friction really matters. And of course the magnet is exerting its magnetic force in this direction into the wall. And so this becomes our normal force. And we know our tangential force has to be this. So that's Fn. And we know the law for static friction, the frictional force Ft is equal to mu times the normal force Fn. Now I'm thinking of putting like a rubber pad on her feet basically. Between the magnet and the wall. Rubber has a pretty high coefficient of friction, but we're going to give a conservative estimate of about 0.6. The magnetic force has to be mg divided by 3 times 0.6. Okay, now luckily Charlotte is very light. We're going to go ahead and weigh her with this spring scale here. It's the lightest spring scale I have. Got around 2 newtons here. For this problem, if we plug in mg, we require F equals 2/3 of a newton, and for this problem 1.1 newtons.
Yeah, but you have the calculator ready, I bet.
No, I don't. I did that in my head.
Whenever you start using bigger numbers, that's when you have to pull a
You
calculator
don't need a
out.
calculator for everything.
Okay, so rounding to 1 decimal point, we need F equals 1.1 newtons. So the magnet needs to be able to hold 1.1 newtons. For the case of F being less than 1.1 newtons, Charlotte will fail. She won't be able to climb the wall. What happens if F is greater than 1.1 newtons? She's going to stick. But that doesn't necessarily mean that she's going to be able to walk. A condition for walking requires that she's able to lift her foot. Now, one way to figure out if Charlotte is going to be able to lift her foot under the magnetic force, go through the whole calculation of what is the motor torque and how does that transfer through the mechanism, but I don't really have time for that. So we're just going to do a quick thought experiment. So recall that Charlotte sort of has this joint on her leg here. This joint is kind of moving back and forth between these 2 configurations, and there's some motor here that's driving this leg up and down. So we know that Charlotte is able to walk, meaning that when 3 legs are on the ground, this motor can exert a force downward of mg over 3. And now the thing is, the motion of this link is symmetrical, and so is this transmission. And that means that this leg should be able to exert the same amount of force upward as it does downward. Okay, so our first magnet variant is with the main poles on this side, so we get kind of a lesser force from this. And let me look here. It looks like it's reaching about almost 4 newtons before it breaks. And if we go through the rubber sheet, that's about 1 newton. That's pretty good. So maybe this is what we want. It's a little bit more than 1 newton, so maybe that'll work. This leg design had the magnets interacting with each other in between legs. And this is something I didn't really think would happen, even though it seems obvious in hindsight. So a new design used weaker magnets and had them sticking out instead of there being a plastic barrier in between them and the wall. So here is Charlotte with all of her magnet shoes. You might be wondering, what are you doing all the way down here? Well, I realized after putting this all together, I didn't have much in the way of metal walls or ceilings to actually test this, but I do have this metal thing here, and so I figure that might be a good place to test her out. So you can see these new shoes, they still interact, but they don't interact as much. She's still able to complete a full gait cycle, which the previous feet prevented that from happening. Let's see here. Just gonna try putting her right here. Oh! Oh, she can just barely. It's hard. It's just not very stable, unfortunately. But I will show you. She can stick, so it's just a matter of the instability caused by walking that prevents her. So next time, unassisted, if we put her on the fridge, the problem is the magnets are very strong and there's no traction. So I'm going to try just grabbing that rubber mat. So if I add this rubber sheet for traction, I'm wondering what's going to happen now. It's still not quite enough. What I didn't consider, of course, were the moments, right? Yeah, of course she can do it with some help, but she's tilting away from the wall, and that's ultimately what's causing the problem. But one finger assistance? Yeah, that's interesting. All right, so wall climbing. It's gonna need to happen another day. But can't say it doesn't look cool. Just imagine my finger not being there. Oh. Oh boy, Charlotte. You kill me. Now, back to the board.
How's it going?
Good. I'm just getting everything set up.
Have you burned a bootloader before?
Yeah, I did it once on an 18 mega chip. I don't really remember how, but I don't remember it being too hard.
Well, this one's an SAMD chip, but it's pretty simple.
Okay, good.
You just gotta hook your debug access port to the serial wire debug pins and flash with the bin file. You know, use the SWD pins, the data, and the clock, and the reset pin. You did design access points for these pins on the board, didn't you?
What, I can't burn the bootloader over USB?
No, that's ridiculous.
Yep, that's right. A programming and debugging interface called serial wire debug is required to burn a bootloader to the board, the one thing that makes the board more than just a collection of silicon and fiberglass. I admittedly completely overlooked this in my design. Wow, am I cooked?
You'd better check those forums. Maybe there's a factory bootloader.
Okay, good looks. I'll check. Oh, microchip forums. This is exactly what I need.
20 minutes later.
Hey, Charlotte, I think there's a factory bootloader.
Hey, that's great.
We are so back. We are so back. I just have to connect to pin 15, which is connected to this.
20 minutes later.
There's no factory bootloader. There's no factory bootloader.
Well, you know what you have to do.
Access the SWD pins on the chip.
Hey, it only has to be done once. Then it's programmable from USB like all the others. Don't forget you need to make an SWD programmer with a QDPY and some firmware.
I don't know if I can do this. I mean, those pins are so small. And I have to solder wires to them?
Hey, it's your fault for designing this board wrong.
That's true. I will reiterate, it's not PCBWay's fault. Not at all. All they're supposed to do is take my design, make the PCB, source the components from my bill of materials, surface mount solder it all together, and ship it out to me. And they did that. Wonderfully. No, this was all me. My design was wrong, but only slightly. Short just 3 pin access points. To be fair, the fact that I made a mistake like this doesn't surprise me at all.
That is true. You do fuck up a lot.
You said I needed a QT-Py for SWD programming, right?
Yeah.
Okay, great.
Hey.
Okay, so what I have to do is try to solder 2 wires to these tiny little traces. It's going to be these last 2 traces on this side here. Those are the pins for serial wire debugging. So what I'm going to do is I'm going to place this in here so it's secure. So I've got some really thin magnet wire here, and I need 3 pieces because I've got to connect to the SWDIO pin and the SWCLK pin, as well as the reset pin. First thing we've got to do is scrape off one end for breadboarding and the other end for attachment. We've got to scrape off the insulator. For the side that's going to attach to the board, we're just going to scrape off the very tip. Next thing we do is tin the tip of this wire. Make sure it has a nice smooth coating. With the tiniest amount of solder on my iron, I'm going to go in and press this right up against the pin that I want to touch, that I want to attach to. Pressing it right there. And heat it up. And you're good. Doesn't take much heat. Okay, so that's attached, but I'm not going to bend it too much because it will break. Okay, and now we do the same thing with the other pin. Now that one's attached too. Now the reset pin is far more accessible. It's literally attached to this button here. Alright, so here we have those magnet wires connected to the board, and these connections are very fragile, so I've clamped them down with my spare pressure vessel from PCBWay. And now we have to connect these to this QT-Py, which has been flashed with this code from the Adafruit debugging access port library. Basically allows you to turn any microcontroller into an SWD programmer. So very cool. Okay, so SWDIO to pin 1. This next one is the reset. That goes to pin 0 on the QT-Py. Then finally, pin 2 is the clock. Okay. Now we do need to make sure our 3.3 volt power sources are tied together. So that is pretty handy because this board comes with the JST connector for power. This programmer is now in bootloader mode. So we're about to put this one in bootloader mode, and coincidentally, not on purpose, these are going to have the same bootloader. That's not how it works. Like that's not always how it works. So we just upload this QtPy, this flash from SD QtPy. So we've got a bin file on this SD card. We're uploading the code, and look at that. So the output from the serial monitor, boom, connecting this debug access port, and it found the SAMD21E18A, that's the chip, and it's programming it with the bootloader, and now it's done. So now we can just break these really brittle solder connections. So when we plug this in, double tap the reset button, that does the same thing that the QtPy does, which is blink red, then green, and that means this is in bootloader mode. So it's ready for a sketch to be uploaded. This is just a test that flashes red, blue, orange, white over and over again. And there's a really bright LED on this thing. I love it. It's way brighter than the QtPy LED. I think it's fantastic. This is so exciting. Huge thank you to PCBWay for making my first ever custom microcontroller board. I can't believe we pulled this off together. This is huge. This means that in the future, all of my designs will have a dedicated circuit board. No more loose wires, no more messy soldering, pure sophistication from now on. Now, as I said before, this board is tailor-made for bracelet design, and we can start by trying to make this wrist-mounted ejector a little bit smaller. In the old design, I used a custom hole mount board from PCBWay and sourced and assembled the components myself. I made a nice compartment for it, but it still has a bit of bulk. The new PCB will certainly help, but I won't have time to make a compartment for this video. We're at 20 hours to go on this video's deadline. What I can do is test the functionality of the board to drive a DC motor in the way I designed it to. I don't have to solder anything to the board at all. I'll just use these handy JST connectors the board comes with. To the other side of these connectors, I'll attach a battery, a trigger, and a motor. It's as easy as that. Finally, we'll upload the same firmware as the old design, with some pin assignments switched around. And then so we're changing the ports from 6 and 7, and then we're going to use this one up here. Okay, and check if the onboard power regulation works. Beautiful, look at that. I love it. Okay, onboard power's working. All right, we've got everything hooked up, sketch uploaded. It's working, look at that. The same program that we had on the other one is running on my custom PCB. How cool is that? Just like that, we have a far more compact valve control system than ever before. I feel like we can definitely reduce the size of this device by 50% or more. Huge thank you to PCBWay for making this possible and sponsoring this video. I mean, seriously, just a few months ago, I never would have thought I'd have hardware like this. It's going to change everything. Go check out the link in the description for $5 off their obviously quite impressive services. I can attest to their quality. Again, the design error was completely my fault, but it led to a teachable moment for me and for you. What do you think? Is miniaturization a fool's errand, or can my dream of wearable self-defense devices come true? Let me know in the comments below. Now, the next step in miniaturizing this device is the battery, and inside this weirdly large box, I've got the little answer. Now, recall before we were using 2 of these big batteries here, and those were put into a casing that looks like this. 2 of these big batteries mounted just kind of like that. 2 of these reasonably large batteries mounted like this in here. And so now we're switching to a much smaller battery with the same voltage. Now the size difference here, you know, it's not magic or anything like that. You can see this one has a capacity of 600 milliamp hours, while this one has a capacity of only 150 milliamp hours. And possibly the maximum current output will be reduced as well. But all I really need for my transmission is less than half an amp. I could actually mount these flat in here possibly. We can probably reduce sort of the thickness of this to be closer to just the thickness of this battery here. So I'm trying for the first time a 3D printer nozzle with a diameter of 1 whole millimeter. So you can see it's going really fast. Both of these parts together is just gonna take like 30 minutes total. Definitely pretty stringy, but I'm not going for settings here. Well, these parts turned out pretty well, all things considered. or 30-minute print. We're gonna see if the batteries fit. It looks like they fit pretty well. Nice.
After assembly, the new battery design was ready to attach to the existing bracelet. And boy, you can see the difference. Before, battery was a significant contributor to the bulk of the device. Now, we're ready to optimize in other ways. And just as important, the battery was still able to power the valve operating mechanism. It remains to be seen whether or not we have enough battery capacity for a consumer-friendly device. In any case, this video took significant strides towards miniaturization, especially with this insanely cool custom PCB. I don't have a whole lot more to say, and I'm ready to get a full night's sleep, so I'll see you in 2 weeks. Support me on Patreon. Stay amazing, and sweet dreams.